It's always so exciting when my tool says, hey, this stream is starting and you are now online and you're now live. I always think, hey, this won't work this time. And every time I see myself in the little web browser there and I'm like, it seems to work. I have adjusted some stream settings though. Wait, first of all, hi, how are you doing? I'm good. Thanks for asking. And I know some of you will probably be asking, which is very polite. Thank you very much. Yes. Hey, it's Christmas time. If you're wondering, usually I wear like a shirt or at least not a t-shirt, but like a shirt or maybe a polo or something. But no, it's Christmas time, so I'm wearing a sweatshirt. I'm wearing my Christmas sweater now. Haven't put this off in like 2 days. Nah, it's fine. I just put it on like today. So yes, how's everyone doing? Right. You probably already saw the topic today. I wrote in the title there, let's talk drives. Right. Already a disclaimer. I am not exclamation point a drives expert. I am good on the PLC side. Right? So that's what we're going to focus on. I've already seen lots of comments like, "Hey, oh, telegrams and those an S120 and a G120 and motion control versus and so on." Like there's so many topics. It's its own field. Hi Dane, hi, how's it going? And everyone else as well. Um, yeah, so I'm not an expert in there. The last time I really had a lot to do with drives was when I was studying. For those that don't know, hey Martin, hi Troll Quantum, hey, welcome back. For those that don't know, I do have, of course, my engineering degree. It's only a bachelor's. I never really aimed for a master's or for a PhD. Fun story, I was offered to buy a PhD once. So I do a lot of trainings also internationally. And in some countries, right, it is rather easy to buy a degree. And some course participants they asked me, "Hey, do you want to buy a PhD?" Because I have to do with a lot of teachers, a lot of also university professors, and they were like, "Hey, if you want to have your degree, like a PhD, just come to our country, come to our school." I'm not gonna say which school and which country that is, obviously, but I was offered and just like, hey, come to our school for like a semester or two. You teach at our school, and in return, you can have your PhD. Of course, you have to still write like a thesis, and you have to make some published articles and so. But in the process, that's not a problem. And I'm like, no. If then I want to earn it, right? So I have, yes, hi everyone else, hi. Um, yes. So I have had the opportunity, but I know if then I want to earn it. Hey Gordon, hi. Uh, yeah, I could have just bought one. A master's degree, I always think maybe I'm gonna put a master's degree in there somewhere, but who knows? As long as I'm still young. I'm heading towards my 40s, so yeah, and it's maybe at some point. Yes. How did we get there? Oh, drives. Yeah, the last time I had to do with drives was in my bachelor program, which is now 16 years. Oh no, I got out of university in 2012, so it's 13 years. So yeah, it's been some time since I've really been doing something with drives. Now in automation though, of course drives is a huge topic and I want to talk about it and I want to start the discussion here and then see where it leads, and I want to show you the perspective from the PLC side of things, right? That's what I have. I have the experience from the PLC side. But yeah, yeah, that's all I can offer there. Let's see. First questions coming in there. Hey Rakesh. Hey Hamdia, hi. What is ProDiag? Good question. I don't know exactly, but we'll talk about it in the future. But it's not too complex. It is very helpful, but we'll see in the future. I can give you a good resource. Wait, I will do some hashtag ad later on. Oh, talking about hashtag ad, before I forget it, don't forget to get my Udemy training there. Don't have to, right? This is just like now the attached thing. That's it. Need to do it. Pinned. There we go. Let's see. So the ad that I do every time is much shorter. Have I worked with SEW Eurodrive inverters? I have not. No. Hey, hey Apostolis. Hi. Hi from Sri Lanka. Ooh, that's far away. Yeah. So last time I really experienced drives was in my studies. That's when I really got into the theory as an engineer, right? And that's the thing there. As an engineer and working in the field of automation, which I do mostly training, right? Of course. Hey, from Denmark. That's not too far away. Denmark is very close. I've been to Denmark. From here, I could be in Denmark in probably like 2 hours, depending on. Probably not by car, but by plane, right? So yeah, from Africa as well. Africa's big. That's you can be a bit more precise there. But yeah, I've never been to any African country. Uh, so yes, so the drives perspective, automation perspective there, I have been doing with drives, of course, but it's so freaking complex. Right? I definitely am not an expert. But we will start the discussion and we will see. I do hope that Jason is going to be here. That's also one reason why I start why I wanted to start with the topic. Then I will hand over to Jason maybe later on, and he can make a video or live stream about drives. And if you're interested in it, it seems like he's got a lot of experience. I scoured through his channel a little bit. Seems like really cool stuff there. But we will start the topic today. Right, a bit. Hello from Russia. That's what I mean. Depending on Russia, is very wide, so could be very close, could be very far, right? Yeah, Poland, that's pretty close, but could also be very far. It's also a very wide country. Lebanon, I've never been. Algeria, India. I've been to India though. It's like 4.5 hours from here. Hey you. uh, I have worked with SCADA software, but I have not used AVEVA or AVEVA. I've basically just used WinCC in all like there's WinCC, then you have WinCC Advanced, then you have WinCC Professional, now you have WinCC what's it now, the Unified. So I think with the Professional or Advanced, I always mix those two up, right? You can like create those big SCADA systems. Hey, there's a lot of people from Kenya. Fantastic. Okay, good. Let's see. What do we have today on our list? Hey, Mexico, different continent even there. I mean, most of it is different country. Africa, of course, Asia, Europe, but also we do have Mexico, so we have the Americans over there. Let's see topics. What I want to talk. Why is that mirrored? This is so annoying. Small talk in the middle of it, almost done. Tunisia, never been there. The Optimite, you just finished your first commission today. That's fantastic. I remember all those. It's been 15 years, but still, that's always cool. Every commissioning is very fantastic. Unfortunately, I've been mostly doing like teaching lately, the last years. I would love to go really back into like the real projects. At some point, I will. Yeah, we're going to talk Siemens drives. Yes. I mean, could be any drives actually, the way I set it up. We'll see. One of the world's biggest paint booths for windmills. I just saw a video like a couple weeks back about painting windmills. Fantastic stuff. Yeah, so small talk, that's where we're in. Then I will set up a new project, right? In the new project, I will talk about very quickly about the new user management process. Right? This is something that I personally struggle with myself, right? Because it is freaking annoying how Siemens did it, but once we talk about it, we are all aware of it and we can all use the new process because this has changed newer hardware, different process. Right? Then I'm looking in the wrong way. This is so confusing because my camera is oriented there. Wait, I can't just do this, right? No, then you won't see it anymore. No, I can't flip anything. I could, but I will not. Then we're going to get into technology objects, which I will use to control a drive. Right? So there's a whole process in there. So I will talk about those three topics for this: technology objects, start drive, and telegrams. Now, those three things, they have to do with drives, right? And they're the base system. They are not really, I'm not entering like too complex, too deep areas, but they are the most, we will enter the most like important stuff, like the base level stuff. And then we will have a nice running program for communicating with the drive from our PLC perspective. Any playlist or videos on PCS7? I have worked with PCS7, but I have not created any content because PCS7 is a very, very specific software. And if I would make a video about process controls nowadays, right, I would not make a video about PCS7, but I would make a video about PCS Neo. That is the new Siemens Siemens process control software. This one replaces. It's like we had Thematic Manager, and now we have TIA Portal, and then you have PCS7, and now there is PCS Neo. Right? So then I would probably talk about this one. But still, it's a long time since I've worked with PCS7. I've never worked with PCS Neo, but sounds to be a solid thing. Nico's with a very good question. Does the new Siemens AI and Copilot replace engineers in the near future? It will change the landscape of tasks that you have. It already does. Right? It will change the landscape of all of the automation jobs. It will not fully replace everything. Right? However, it will definitely impact a lot of the processes. Yeah. If I would think that it would fully replace everyone programming, I would not be doing any videos about programming anymore. I would just do videos about AI. Hey, this is how you use AI. No, I believe in the things that we're doing and that you have to have the knowledge for the future as well. I mean, AI is important. God just goes with lame AI. AI sucks. It is a tool. Currently, it is a tool, and that's what I would like to see it as well. TIA Portal is a tool. You have many programming tools that always helped you with code completion or so. There is nowadays vibe programming, so you don't really have to be a programmer anymore to get code. But we are far from like replacing all programmers, especially right in the field of automation, where AI and AI programs, they learn from existing code. They have to be taught, right? All AI is based on like intellectual property. And for industrial programs, you barely have any public information like of how programs are developed, right? It's all very, very restricted programs. So the AI cannot grow as fast. Even the Siemens one, it can grow, of course, but it needs way more data from my perspective. But I can't see the future. Definitely, programmers are still in demand for a longer time. Let's see. With TIA, I prefer technology objects. Yeah, I will talk about technology objects today, Murat. Yes. Let's see. Do I have a free course for students? Suma, just check my YouTube. Right? I don't have a free. I mean, it is free. Right? If you check my channel, okay, that's the last small talk. I mean, we're already almost in the topic here, but I have done something that I wanted to do for a long, long time, and now I finally got to it because I'm not as lazy anymore currently. And soon we will start with the topics today. If on my channel, right, on my YouTube channel, who asked it? I don't know who asked it, but there, Suma, you asked on my YouTube channel. What? I'm mirrored. This is so annoying. If you just scroll down, right, you will have like all of the playlists here: beginner level, TIA, intermediate level, expert level, and so on. Like you have those, and they are all free. Just on my channel, just scroll down a little bit. All of this is free. That's what I want this to be. There we go. Hey, Emma, Finn. Hey, hi. Good evening. Transfer program with an MMC card. Have I ever transfer? Yes, I have transferred programs with SMC, not an MMC, right? For Siemens, those are called SMCs, semantic memory cards. I have transferred programs with those, yes. SMC, Siemens. Semantic memory cards, are you kidding me? Those black cards, they are called SMCs. They are not normal standard memory cards, right? Not micro memory cards, they are called SMC, the black ones. But I have transferred programs with those, yeah. It's not difficult. You just have to do a little fiddle around. I don't have hardware here, so I can't make a video. Can't really show it, but yeah. Let's see. Ask chat to do STL, STL for you. No. I do like to create my code myself as well. What do you need to know to start to really start working as a PLC programmer? You just have to get into it, right? Now, yeah. Like good pointers are like the getting started, that the official getting started from Siemens. They are also very excellent. I will not just self-advertise all the time. If you want a good start really into the Siemens world, of course, my YouTube channel is great, but I always also point for beginners. I point at this resource, which I will now switch to English, and I will share the link. Right, this resource is free, right, and it is a ton of learning material, right. And it helps you with getting into all of those topics. There's a ton of different topics here, right, including PCS7 modules, all of it free. Right? You have to make a Siemens account, but all of this is free. There's a ton of free learning documentation, the official Siemens documentation. So if you are interested in any like official, like, hey, how does this go according to Siemens? This is a very good resource. It's free and official, not like my YouTube channel. My YouTube channel is me just making up nonsense and talking from my experience, of course. When migrating step 7 version to the latest version, do we need to download the program to the PSV or can we monitor? You have to, hey, Tech Trends, asking when you upgrade your project on your PC, your offline project, can you still monitor what's on the PLC? No, you have to have the same version then in the PLC as well. That is why like keeping the project versions consistent is important. Yeah, as Rakesh says there, my YouTube playlist is also good. But there's many resources. Okay, good. Small talk, right? Small talk, we're good, I would say. Okay, let's create today's project, and I also then want to get into something I completely forgot. Last week I have created this thing here. This thing last week I have created the library TIA Tuesday that I want to publish, and I have not published it anywhere. I still have to do it. What I will do today is whatever we create here in our project, I am going to push into the same library, and I'm going to publish this library at somewhere. I will definitely make a post maybe and let you know where that is. But I have not forgotten, I have just not done it. So questions there, Mr. Goodman. Am I planning to talk about OT cybersecurity or OT IT integration? Cybersecurity, I'm not too good with the topic, I would say. It is an important topic, and it's very important that you don't make any errors there. So I don't feel too comfortable talking about it too much. I will put it on the list here, but it's definitely a topic that I also have to get into. Right, so I will put this here in the communication. IT, OT, security. Definitely important, but I'm not an expert in everything, unfortunately. Not unfortunately, I couldn't. No one can. What software? So Anthony has a question there. What software can I use to simulate drive programs? Hey, Ateko, hi. Hey, Kamal, hi. YouTube channel helped a lot with learning. Yes, that's why I have the YouTube channel. Happy to read every time. So there, Anthony asks, what software can I use to simulate drive systems? None. No, the official Siemens software that I have been recommended personally by Siemens personnel, which I don't like to use for that. But this was always like, oh, use this software for it. Right? Is Siemens Siemens, this thing here. Right? So Simit is a software that is a very advanced simulation software, and you can integrate drives with this. Whenever I talked about with Siemens drives guys, they said this is the only software that can really do it well and so on. And I'm like, yeah, I'm not going in there. But this is the one that I always have been recommended. Yeah, Murat also said it. Yeah, the Simit program. Yeah, exactly. There is also a guide to it and so on, but that would be the one that simulates a lot. Like you can simulate a lot of things. PLC Sim, right? PLC Sim is the software for simulating your PLC, and Simit is the software for simulating everything that has like a machine behavior, which includes drives, which includes many more components, right? So the components themselves can be simulated by Simit, which is yeah, but Siemens it uses a license like everything in Siemens uses licenses. Yeah, so I will not be simulating a drive system, obviously. Yeah. And then the next higher level of simulation would be virtual commissioning with Siemens NX. Oh, that's wait. I will actually make myself smaller because now we start. I started talking about real topics here, right? Can you simulate really dynamics? I am not 100% sure. I would say theoretically, of course. Practically, I wouldn't. Right. You see here, this it can high quality DCS engineering and so on can do a lot. I would have to look into it as well. Yeah, the other software that you then connect another simulation software, the highest level, would be Siemens NX MCD. Ugh. NXX? Did they rename it? No. NXCAD. There was the MCD. The MCD was the mechatronics concept designer. Great tools. But Siemens NX is then mostly used for like machine simulation. There's so many different levels. Do I know Proneta? Yes, but that's been 20 years since I've really worked with it. If I could add an RF handheld remote video for machines, I probably will not. Sorry. So many questions there. Sorry, I can't really start with the topics, but that's okay. I will try to solve as many as I can, as quickly as I can. Can you do some safety connecting and programming to fail-safe PLC? It's good because you're asking very specific questions, and they are easy for me to answer because I have to say I personally can't, like not from the simple prompt, I would say. This is where AI would be very handy. That I would just pump your question into an AI and it would answer that. But I don't know, sorry. T. I will be in Ruckheim tomorrow. How's the weather in Germany? Weather depends on. It's quite rainy, but it's nice. It's not too cold. It's quite warm today. So me wearing this is way too hot, actually. If I would wear this outside, I wouldn't need a jacket currently. It's okay, like +5 Celsius degrees Celsius, I would say. So it's okay. But of course, Germany is also big, so I just know it in my region, which is not near Ruckheim. Good guidelines. I can make a good video. This is already on my list there. Can I make a video about good guidelines when PLC programming? Yes, definitely on the list. Ali there with the German question. Hallo, Privatunterricht ist sowohl persönlich als auch online möglich. Wie kann ich mich mit dir in Kontakt setzen? Well, here basically. But I don't do private lessons. If you need me, if you want me as a trainer, it's pretty hard. I do some Siemens official trainings there. They send me out as a trainer, but I myself haven't done any personal training, sorry. But I can recommend, if you need personalized training, I can recommend the official C-Train website, right? C-Train is the official training department of Siemens. So if anyone ever really needs official Siemens training, right? It is C-Train. That is the official Siemens trainings. And I am on their list of external partners. Okay, let's see. 23 minutes small talk. That should be good enough, I think. Have I worked with raw data types, particularly found in WinCC? I have. Not tech trends. I will just go through the next question. I'm like, no. Let's see. Do you know about how pixel to millimeter conversion works and use of vision systems and gantry controls? I do know about the theory, of course. I would have to, of course, inspect the tools that you specifically mean, which I would probably be unfamiliar with. AI and automation works sometimes, like AI overall works sometimes, and sometimes it doesn't. It's a tool. It's a tool that assists, right, in most fields. I use it myself for programming and also for, like, instead of Google sometimes and so on. I do use AI, but I'm not relying on it. I don't trust it enough that it gives me a good result. So I use it as an assisting tool. Like I use Google, right? Like I use Excel with like spreadsheets and so on. I do use a lot of tools. AI is one of them. It hasn't replaced me yet. Do I have any experience with flying restart start on Siemens G120s? I have not, but we can have a look at that. Actually, today, if I can get in there. Servio, maybe I'm late to the party. What about Factory IO? You've seen me use it, yes. One thing that why I'm not going to use it today is because I have not gotten a license. Because I will in the future, but right now I don't need one. So the trial license is gone out the window. Let's see. Will that work for simulating drives? Depends on, but no. Factory IO does not have drives integration. It's just like a 3D mechatronic system. It's not technical components. It pretends to be. It's on a very, very superficial level, but not really technical components. No. Which tool do you use to restore an SMC card? I felt TIA Portal, but like if it's gone, it's gone, pretty much. Have I ever used IBA? Nope. I have drank a lot of IPA in the past, Indian Pale Ale. So, but IBA, I have not used that. I don't know what it is. Sorry. Let's see. Oh, so many questions. I will answer 2 or 3 more questions there. By the way, today the delay in the connection, so I can way more directly answer to your questions because I have set the delay in the connection to a shorter time scale. That's also why I try to answer questions as fast as possible. So I will put IBA on the list here. I don't know what it is. I've put it in under other tools. Seems to be a great tool. If you say so, I haven't used it. More of 1, of 2, it's the most complete. Yes, tech trends. Tech trends, perfect. That is the transition I needed. Tech trends just asked. I would like to understand more on of 1, of 2, etc. The most commonly set in drives. Thank you so much, Tech Trends, for giving me a transition. Finally, I've just been answering questions here. We will now enter the world of drives, where I will also talk about of 1 and of 2 and so on. Perfect, right? Opening the gate into drives here. So small talk done. Let's create our project for today. IBA process data acquisition analysis. Perfect. I will copy this and put this on the list because there's probably more than one IBA. IBA, PDA, personal data system. That's what PDA for me is. Let's see. No one program for automation guy in maintenance IBA. Yeah, it seems like it's an important tool. I will Google it later on. I will not get into it now because I don't know anything there. So last question that I will answer right now. I will try to, of course, get in there, but I want to start with the topic. Mario. Hi, Mario. Asks if I have taken C-Train. I personally have taken some C-Train trainings, yes, and they are always very high quality. Right? That is like C-Train is the official Siemens department, very good. I have taken a couple of trainings as a participant, and I have also given trainings. Like last week, for example, I have been giving I have been teaching a C-Train class, and next week I will also be teaching a C-Train class. Right? They are high quality. Like most of the trainers are much more qualified than I am. Yeah, but so I can recommend C-Train. Yeah. Of course, it is expensive. It is like Siemens quality, industrial quality, not like my cheap YouTube videos. Right? That's a completely different topic. For example, here, their visualization. What is that, for example? Low quality here. Visualization. I don't know. Visualization. Kind of like this. What does WinCC 8 differ from WinCC and TI Portal? Haven't read the differences. Haven't read any changes. There we go. Hey Jason, hi. My videos are priceless. Hey, I can differentiate, because your name is now blue. Hi Jason. Perfect. I have already announced, right? I don't know how long you have joined, and now I will actually get into the topics here. I've already said I am absolutely not an expert with drives, right? So I've already said I am going to start the topic now. right? And I will basically go into like the distance where I will talk about telegrams and about, hey, this is this. Now the PLC side of things is done, right? We of course have on the other side the drive side of things. We can communicate to a drive, we can control a drive, but actually, what does the drive do? How do we configure that thing, and so on? This is not. This is what I cannot talk about too much because I'm not an expert in this. But this is where I will like send people to you basically. The drives. I know the drive side is the fun side, right? So the next one is on you. So that's where I want to end today, kind of. Hey, Avijit. I'm really a TIA god. Nah, I know people that are way better than me. I can explain things. I understand TIA and I can explain things quite well. Yeah, that would be true, I would say. Let's go and start our TIA project for today, right? And then hopefully I will not go like for 5 hours this time. I want to keep it to 2 hours. So let's create our new project, right? Every week a new project with the library here. I will publish this library at some point when it is already filled a little bit, maybe or so. But it is there, right? We do have the library. So the first thing that I want to talk about today, the first technical thing here in TIA Portal, is I am going to choose an S7 controller here. And an S7 controller, the drive side, is that a pun, Arteco? The drive side runs the world. It does, right? Those drives, they run everything. They move, right? Oh, you could have said they move the world. They run. It doesn't matter. But yes, of course, it does. So, right, I now chose a TIA, a controller here, right? A controller that is firmware version 4.0, right? Now, in the past, the user control and the access control to PLCs has changed quite a bit. Right? And of course, I have not really talked about the newest version, except for me complaining that there is a new version and that the new version sucks and I hate it. Right? Now I want to take like 5 minutes to talk about it. Right? I will not look at different YouTube channels right now, but maybe I'll put it on my list. My T-shirt is this is like my Christmas sweater, my ugly Christmas sweater. Yeah, so this one here, right? Firmware version 4.0 is the newest firmware version as far as I'm concerned. Maybe 4.1 or so, but like that's the most recent one, and I will call this PLC drive. Right? It's version 4.0. Now, when we nowadays set up a PLC project, there will be this pop-up, right? This pop-up is nothing new, but what we get in this pop-up is new. And it talks a lot about the user management and the access level to TIA Portal. Right? Yeah, but Arteco, you're right. If you are running a successful firmware version, try to upgrade it if you know what you're doing. If you don't know what you're doing, don't upgrade it. Never change the running system. Unfortunately, firmware upgrades have to do with safety. Right? And industrial data and your systems, they should be protected as much as possible. So a firmware update is sometimes crucial, as unfortunate as it is. Hey Rakesh, hey Raphael. Hello. Brazil shows up like a lot there. It's pretty cool. Yeah, also Jason, all right? Now you have the mod status. Follow Jason as well there. He's going to explain the drive side of this, what I'm doing now, at some point. Okay, most of this is not too important here. I will turn off the PLC protection. We still, however, right, have to have this. This is the new thing, right? This is the new thing. You have to have, you can disable access control, but this, of course, lowers like safety and so on. This is not what we want to do. We want to enable access control. And this is the new like user management that we have. This new user management is different from what we had. In the past, everyone could basically everyone could program your PLC except for the ones that you set specifically in the PLC hardware and device configuration. Right? So you had to create the PLC user in the device configuration. That has changed. Now the user, right? The users will be saved inside of the PLC. However, they are currently in like a global in the project, right? They have to be set up globally inside of the project, right? They can be in the project itself, or they can be on a server and they can be synchronized with the server, which I will not set up now. But we have this stuff here. Yes, the firmware update will change signatures. Yes, unfortunately, yes. Rebuilding is not great, but unfortunately, sometimes it is necessary. Sometimes, and Jason is right. Sometimes, not talking too much about firmware now, but of course, if you have a running system, don't change it. Try. Right? And now, like the rest here is unimportant. We don't have a management server. We let me see. Administrator. Yes, this now is important. The administrator setup. Right? Now, the administrator setup is the person that has access to the PLC. If we do not have an administrator, we cannot. So we can download the PLC one time, but afterwards we can never download the program again because the PLC is now locked without user. Right? So we have to have a PLC administrator. Right? Which I can select now. I could create a new project user, which would be valid for all of our PLCs in our project. I will not, to just emphasize on how I don't like how this is integrated. But right now we do not have a PLC administrator, which is bad, right? Which is bad because we can do this now, right? The next is access without authentication. Now this will grant. And this is what we have to do, right? This will grant the anonymous user the access rights to the PLC. Now, and the anonymous user is everyone without login. Now, this will allow us to download PLC programs. Right? It's kind of stupid, but you have to kind of go through this process here, right? And you see now, I cannot change the access level here. There's nothing I can change because the access level is now like on a global scale fixed. We have told, hey, yes, the anonymous user is allowed to do stuff, but that's it. Right? If we don't do this here, we have to create a user. There we go. That's just the new process. There is now still one thing that won't work, and we will see this in a second here. If I now try to compile my program, that should probably be without. No, that is already with the problem. Yes. You see, if I compile my program now, my PLC, it will give me an error. Whoops, I cannot download. I clicked the wrong button. But while this is loading, I can now read questions and so on. Hey Ben, hey go. Would you ever consider doing code reviews? I don't really do code reviews. Sorry. It would be maybe on TIA Tuesday. Maybe I can do live code reviews. Oh, that would be something interesting. But I also am not confident enough that I should do it currently. Yeah. For students and so on, for beginners projects, yes, but for real industrial projects, could be quite difficult. There's still the drives and firmware discussion there. Hey, Artux, hi. How are you doing? Performance differences between languages. CRC error. CRC error gives a very... There's a good question, so I will interrupt what I'm doing here for a second. So I put a pause on this, that we have a compile error now. Right? CRC error asks the question, if we know that if there's performance differences between languages. Generally no, but generally yes, depending on what you want to achieve. Now, if you have a function block diagram or ladder diagram and you basically create the same program, they have the same performance. That's it, right? Those are designed to do the same thing. Now, if you use S7 graph, right, that has a different purpose. So you cannot like compare two things that have different purposes. You can create the same behavior in the end, but of course, if you have like a sequential program, graph will always be more potent, more like fitting, more performant than whatever other language you create the thing in, right? Because it has this purpose. Yeah, timing and space. That's what. Yeah. Of course, that's what I mean. Yeah, that is what performance is in the end. Yeah. So you want to choose the correct language for the correct job. Now, the only languages that have the same job nowadays, the same purpose, are ladder diagram and function block diagram. And those have the same performance. Yes. Right? Now, the other two languages that you want to look at are SCL. SCL is this coding language, which is a different thing than function block diagram and ladder diagram. Right? So for more complex algorithms, that's what you choose. Right? So it's a different thing. And then you have graph, which is also a different thing for sequential things. So that is also different. Now, theoretically, you also have a STL, statement list, but that is out of the standard. That is the worst. When it comes to performance nowadays, it's the worst, STL. Right? Yeah. So let's see. How goes recommend Ren and having fun with program ideas? Ooh. I mean, of course, also every other program here except for TIA, right? Hardox, have fun with those programs. Let's see, Ateko, you can switch and fly between ladder and FBD, and I think STL. You cannot do STL anymore. STL is a dead language, right? In step 7, in S7-300s, yes, the architecture has changed. The hardware inside of an S7-1500 PLC, right? In an S7-1500 PLC, the hardware for executing STL does not exist anymore. So it has to be emulated by the PLC, and then the code has to run, which is an additional level of hardware implementation, which is absolutely bad for the performance. STL, if you use STL in an S7-1500, it's the worst language that you can use when we talk about performance. In an S7-300, it's the best, but that's so old, right? Yeah. There we go. Make the WhatsApp group at all. Oh, I don't know. No. My cell phone would go crazy. I don't want that. Kann ich eventuell erklären, zeigen wir mal Statusabfrage für Eingänge. EB, I mean, that's the basics. You would have to go into like the other YouTube videos there. Sorry for now. And it's also German. I will not switch to German now. Yeah. There we go. Enough. STL is dead. Yes. Assembly language is literally slower, Jason. Yes. STL is dead. 1 second. What's the programming standard? I always mix it up. No. What's the PLC programming? PLC programming. I forgot the number. How could I? 61131. Yeah, this one. Sorry, I had to Google it on the side. So the official programming standard, the international one for PLCs, states like the programming languages, and it this is structured text is still in there, right? Here, instruction list is a low-level assembly, like STL instruction list is this low-level thing, but that is out of the standard. If I use Wikipedia for everything. If we use this, right, look at this instruction list. This is my favorite language that is on Wikipedia. Right? STL, instruction list. AWL, that's the German. AWL is in German, that's STL in German, is no longer included, is no longer part of any standard. STL is dead, right? You are using it on older hardware, you don't use it on newer hardware. STL and pointers are dead. Tant Costco, that's exactly what I'm talking about. We don't use those anymore. It's not me saying it, it's the standard. I just say what the standard says. This is scene showcase. You're right. Sorry. Back away from small talk. I mean, this is technical stuff. We have a Discord chat. Yes, I should go. I'm sorry, Jason. It's what it is. It's not me. Okay. So, let's. If we are afraid, we don't use jumpers and like pointers anymore. We don't. It's not necessary with all variables and tags nowadays. We just don't need that anymore. We don't look at memory locations inside the PLC. We do have variables. We have tags for everything. That's a whole other discussion. That I conclude here by saying it's out of the standard. There is no discussion. It's dead. If you create STL code in your Siemens PLC here, right? If you create a block and you make it STL, this block will be the least efficient block that you could write. Literally, because the hardware does not have the necessary registers anymore. It literally is the worst. S7 1500s. 1200s can't speak it at all. 300s, it's still the best. Cancelled. We will. Rakesh, that's the problem with me. Yeah, there we go. So users, right? I have created the PLC, and now when I compile, it actually does not allow me to compile anything because no one has full access, right? Drives, Jason, perfect. So I have to create a user here that has full access. I just double click on this, and this is now the settings for the complete project. So if I have 10 different PLCs, they all use the same user here. And the anonymous user, or any user that I could create now, has to have the PLC administrator active. Right? This user role, right? This user role, the PLC administrator role, has to be activated for at least one user, which is here in the security settings in the users and roles. That's where I am currently. So this is a setting that when you're using a version 4.0 and newer PLC, this has to be active. Usually you would, of course, create a new user, give that user a password, and then, right, local user, and give that a password, and this would be your PLC administrator. And then your PLC would be password protected, right? But I will have no password protection, anonymous. Everyone can override my program. Artico, your first PLC stop in production was due to loop in STL. Yes, one reason why we don't do it. Hey, Kambis, I never realized that it is Title Tuesday. I have watched a couple of Magnus Carlsen matches, and so of course on Title Tuesday, but I never realized that it is. No, that was not my intention. Can I go through the ISA 88 standard? I don't know what that is. I will put that on the list in others. Okay. That sounds like a lot of work to have like a passive, but that is how TIA does it now, right? So in the future, you will always have to go through that, users and roles, and then the anonymous or any other user has to have the access rights here. And this is the least access rights that you need for PLC programming. Yeah. I could now actually also deactivate the PLC user because the PLC user is included in the PLC administrator, but I will not. There we go. And now if I compile, everything's fine again. Hallo, lieber Hegemann. Hallo, Onur. Showing the visualization where the maintenance technician can see inputs outputs without access to the program. Oh yeah, EB. That's easy actually. That's just like having your tags on an HMI. There's probably a video about it I have done. Hey Mark, but why do you just write my name? It's misspelled, by the way. It's 1L-P-P. It's the German. Everyone misspells it. Everyone does. It's fine. I won't take it. Like I had a boss when I was working for Siemens or with Siemens for a long time, for like 8 years or so. That guy wrote my name wrong. Like after 8 years, and I was so, how do you still write it wrong? You can do it. For you, it's fine. Go for it. But my boss back then. Modbus communication is already on the list, Nathaniel. Yes, definitely on the list. If you work for Siemens, use this official Siemens stuff, Mark. But thank you. So, okay. Now, we do have our PLC, and I want to simulate it very quick. Right, simulation. I turn my simulation on there. I will disable. No, this is the standard stuff. We've had this. There we go. So I do not have the PLC Sim Advanced license anymore, so I have to use the PLC Sim Soft Bus, which is okay right now because I'm not communicating to any other devices. In the future, I do have to get the advanced license, though. Yeah. And now I can download. And now every time that I download to this PLC simulation, the anonymous user can be used and will be used. Right? We have set this up. The anonymous user can access the PLC without any password access. That's what we have set up. That's too much caps. Is SODT timer retentive? You can. Abhishek asks if the SODT timer is retentive or not. You can turn on the timer to be retentive or not. Very, very quick, just to answer Abhishek's question, because that is like 15 seconds. By default, they are not retentive. Right? Oh, the SODT. Is the SODT, is that the old one? Oh, the SODT, I have no idea. Don't use it. That's in the legacy branch there. Those are hardware timers. I don't know. They are not. I think they are not retentive because hardware timers, they cannot go into the. Whoops. Right. I could be wrong on this, but if I look at my PLC, if I look at my resources, no, at my assignment list here, you see you have inputs, outputs, you have bit memory. This bit memory has one big area that is retentive and one big area that is not retentive. And then you have the timers and counters right on there. I don't think. Oh, yeah. I want to say, I don't think they can be retentive. They can be retentive. Here, look at this. Right? If you click here, boop, 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 retain data, you can say how many timers starting at timer 0 should be retentive. So your manager is old. The SODT stuff is S5 timers, S5 counters. That's very old stuff. You can still use it, but it's hardware stuff. Now, I don't want to get back into efficiency when it comes to programming. Now, the Siemens PLC has the S7-1500, especially has hardware for this, which is kind of stupid, but that's what it is. There we go. Right? But you can make them retentive. Yeah. But this will always start at timer 0, right? So if you only want timer 5 to be retentive, that is not possible. You can only have timer 0, 1, 2, 3, 4, 5 retentive. No gaps in between, right? Always starts at, that's what this says, right? It always starts at T0. Almost has, hey Dora, hey. Those things are older than me. S5. Come on, S5 is S5. It's got to be older than me. 1 second. Siemens S5, step 5, is older than me. I think so. Ha! It's older. It's older than me, yes. You need to, like, the retain settings are the stop-start thing. So, yeah, it will retain the state after stopping and starting. What is the first S? It didn't exist. Siemens made step 3, step 5, and step 7. Don't ask me why. I don't know that. I read into it and I forgot about it. It is S3, S5, S7, yeah. Okay, so good. Now, user management done. Right? There we go. Let's get into drives a little bit. Good. Okay. We're still good on time, right? I've not been stalling. I'm not an expert in drives. That's what we will find out very soon. But what I want to do is in my program here, right? So my PLC itself. Hey, Rodrigo. Hi. Very helpful. You're welcome. So in my program here, I do have my main branch, which I will not use, right? Now the drive itself that we will communicate with, right, will be communicated with using hardware, right? Using hardware, using a TO, as Jason says there, using a so-called technology object, right? Now, if you want to communicate to a drive, if you want to control a drive system, right? Usually your main function is too slow a lot of times, right? Because it happens like every millisecond or so, and too inconsistent when it comes to the timing. Right? So you will have to integrate more consistent timing things, which will happen automatically. So what we want to integrate right, is a so-called technology object here. Right? Now, drives. Right? And you will see a better picture soon that TIA has integrated. But basically, right, the perspective that I have is I do live inside of my magical bubble. That is the PLC. Right? Now, my magical bubble, the PLC here, I will control a huge mechatronic system. I'm kind of the manager, right? And there are many, many subsystems inside of a mechatronics system, right? Now, one of those subsystems is if you have, for example, a conveyor belt or a lift system, whatever we have, right? Anything that needs to be driven, right? This system, right, of course, has inputs and outputs to our PLC, so there is some communication. Can I draw on this? Yeah, there is some communication going on. Right? But most of the time, like this conveyor does have, or any other kind of systems, they do have much more complex demands when it comes to driving them. Right? So I will have an arrow. This is now my drive here. Right? Now this drive is much more complex than your usual sensors, your usual actuators. It's not just on off. It's way more complex. Right? This drive system will help the conveyor to do whatever it's supposed to do. Now, there's a lot of technology in there. There are experts like Jason there, for example, and correct me if I'm wrong, but I would just push the expert level now on you. Like there's a lot of people that focus on the drive systems themselves, right? Where the drive system itself is supposed to drive the conveyor here. Right? There is so much mechanical stuff going on. There is so much electrical stuff going on that I am afraid of. The PLC world for me is 24 volts. I turn things on, I turn things off. The drive is a lot higher, right? Now, usually, like if you look at electrical machines, at the motors themselves, they are driven with 230 volts, 400 volts, depending on the levels, could be higher, could be lower, but they are way different. There's a lot of kinematics going on. There's a lot of stuff that calculations, everything that is moving like is in there, and I am not an expert in this, right? And there's no shame in this. Engineering and mechatronics and automation and industry overall is a cooperation of so many parts, right? So what I can do though is I can set up a program inside of my PLC that is going to... Why can I not draw? Oh, come on. Let me draw. That is going to communicate and control the drive here on different levels. Right? So we will touch a level now that is not the biggest level, but still, like I can control the drive a little bit. So Jason works with those drives since 2001. Yeah, that's quite a bit of time. Version control and documentation features. I mean, that's a pretty base level feature, but I will put it on my document here, which I've closed. Why would I ever close my document? 1 second. Yeah, so that's the thing, right? So we will concentrate on the PLC side of things here. Just 1 second, I want to have my document open so I can take notes. For whatever reason, I have closed it. TIA Tuesday. I'm one of those people that if I don't need a folder, if I don't need a tab, I usually close it. So there was the... Yeah, there we go. Video communication. RS485. I will probably not touch RS485 for now. Good, okay. So what I need to do though is this outside component, this drive is very complex. Right? Very, very complex. Right? It is. Like there's those drives, they can have hundreds and sometimes even like not thousands, but reaching into the 1,000 different parameters, right? They have a crazy amount of variables, a crazy amount of intelligence going on in themselves. And I don't need to touch this. From my perspective, from the PLC, what I will do now is I'm going to create a technology object. Right? Now, a technology object. There's different types, and I've already talked about technology objects a little bit. I will now use the one that I'm most familiar with, a speed axis here. Right? Now, a speed axis. You see the speed axis technology object maps a physical drive in the controller. I can issue commands for default speed with a drive with PLC open motion control instructions. Now, PLC open is a standard that is not Siemens, right? So I could, with this, connect and control an external drive that is not just Siemens, but any other device. Right? Of course, if you stay in the Siemens world, it's much nicer, but yeah. Now, one thing that I have already said is that the drive itself, the communication to it is very time critical. And you will see the use of technology objects affects the temporal behavior of other CPU execution levels, including the F program. This is extremely critical. The drive itself, we will not have a complete drive inside of our PLC. We have assisting things to control it, but we will not replace the whole drive itself. That will be very critical. It already is going to slow down our PLC tremendously. Right? So if I add the speed axis here, I will not give it a nice name. That is a nice name, and I'll hit OK. What you will see is that the PLC is going to create subroutines automatically. You have a motion control interpolator and a motion control servo. Now those, right? I can't go in there. They are know-how protected, but they are for all of the things that the controller needs in order to communicate with the drive. Right? Many things are in there. And now, can I still go online? I want to do one thing. Yeah, I can. I have not talked about interrupt priority. I probably did, but let me actually get in there. Portal features. Interrupt priorities. This, of course, leads into that topic. Yes, 100%. So right now, Speed Axis 1. Yes, I will not rename that. That's fine. You see right now, my PLC program takes approximately nothing, right? Every millisecond, the program just runs, right? That's the green number that we see there. The green number is how fast is our PLC. Now, and therefore I will need to make one click here. Now, if I download my PLC, I think that it will now have a temporal, I'm not sure. I've actually never checked this out, but it should have a effect on our cycle time already. So if I go online, maybe not. Nah, we can't really see it. We can't really see it, but if it would be more complex, a little bit more, we could have already an impact on the cycle time. I mean, we can see it a little bit. It's 0.0003 milliseconds more, 0.001 milliseconds, but it is longer. It is. Right? Will I make a video about ASI bus? I have it on my list. ASI is definitely on the list. There we go. Right? So this is now for our motion controller. Now, one thing that I want to do already is I like to visualize things, right? And I want to have you visualize right now a conveyor belt, right? So you are running a conveyor belt, and on the conveyor belt, right, you have boxes. You have stuff that is very, very critical, that is not allowed to break. Right? After 4 years, hey Kumar, hi. I've been back for, I think this is TIA Tuesday number 6. I think it's 1.5 months now. Yeah. So what I want you to imagine is that, right? So what I will do now is, and I've done that a couple of times by now, right? Is I will take my speed axis and I will trace some parameters that I want to trace right now, right? So I will go here into my traces. I will add a new trace, right? This trace, and this is very fantastic what we can do with the speed axis here, right? And by the way, for my speed axis, I have changed one parameter that is called virtual axis. Now, this virtual axis parameter is important right now for what we're doing. It tells me that there is no physical control, that there is no physical drive that we want to control right now. Right? You see, if I don't have that, I will need a physical drive, but right now I don't want to. Right? So the PLC itself is going to make a lot of decisions here. So in my trace, right, I can select my speed axis, and you see when I select my speed axis, only one click. Right? Only one click selecting it. On the bottom here, in the details view, we actually have a lot of parameters that I want to talk about. Right? Of course, let's talk about the velocity. Let's talk about the acceleration of our conveyor belt, and let's talk about the, I think that's the velocity and the actual speed. No, the set point. The set point I want as well. And then I want to reorganize this a little bit. Here we go. Right. Now, I will re-download everything because this needs to be in the controller. Oh, I didn't need to write the thing here. That doesn't matter. Now, what I will also... This is new for me. Record events of technology objects. This function allows you to record a motion controller. This is interesting, but I've never seen that, so I will not touch it right now. So what I want to do is I want to... I want to have a longer trace here. I want to just monitor the thing, and that's it, I think. Yeah, no trigger. It's just monitoring. So let's push that into the machine. Right. Let's look at the trace here. Let's go with the scaling. Like, this is exactly what I've done the last weeks as well. I do love traces. Right. Tracing is fantastic. So right now, everything is 0. Right. Everything there is 0. That's perfectly fine. And what I want to do is the following. And I will have to split the editor window for this. Yeah. And I want to split the editor window so we still have the trace here. On the other side, I want to have... Yeah, I was wondering. Yeah, it must be a version 20 thing. I've never seen that. What I want to do is here, I want to go into the commissioning of my speed axis. Now, normally in your PLC program, right, you just have like an output for your PLC for a motor that turns it on or off. Right now, what our PLC has control over through the technology object here on the right side is a lot of drive parameters. Like things that we can tell the PLC, that we can tell the drive, hey, please do many things. And actually there is a lot of things going on. And I won't go too much in detail, but the first thing here is I activated the master control. This will be connected to a G120. So Nova asks, what about G120? This is what you connect to the G120. I'll get to that in a second. Right? The master control here. There's usually 4 different areas that can have the master control. Right? The drive itself, if the drive itself has the master control, like there is an operator panel on the drive itself, right? If the drive itself has the master control, you can use the operator panel on the drive. The second is your PLC program can have the master control. Right? The third is you can have the master control through any kind of interface, right? And the fourth is your commissioning, what's it called? Yeah, the commissioning window here. Right? So I have activated master control right now in the commissioning window, meaning I am the boss of the drive right now. I can control, not the drive, but the technology object right now, which will connect to the drive. Yeah. The second thing is we have axis. Right? Axis, if I click on enable here, there is an internal error. What the what? That is new. What? Exactly why? I've tested this. I have tested this, and I'm pretty sure it should work. Master control. Yes. Enable all axes. Interesting. What? Oh, screw you. That's new. Just 1 second. I mean, I have tested it with PLC Sim, yes. Give me a second. I have tested all of this, so it definitely works. I don't know why it does not right now. So this, by the way, is just safety because the drive is very dangerous. Internal, I do love it. So this happens to me as well, right? Internal error. Like, what is the error? Please, TIA portal, let me know what the error is. It doesn't. So what do we do if it doesn't give you the error? There is a commissioning tool. There is a Nova. There is a commissioning tool. I will get into that. I will get into it in a second. So this is an internal error, and I literally don't know what it is. So I will have to restart my PLC sim here and TI portal. Which should take only a second there. Should work now, hopefully. I mean, no, I don't need to set up anything. I'm very sure. The daily problem is now everyone is like, oh, that, of course. I can always be. So I will have this. I will simulate this. Yes, we'll disable other interfaces. It says, usually it says restart the PLC or so. Right now, the main problem is that I'm doing like simulation stuff. So it might have to do with the simulation, and it might also have to do with the user settings. But I have tested this early on, so it shouldn't. Just give it a second. Could always be, right? That's also something we can learn here. Never freak out. Stuff like this happens sometimes randomly. It shouldn't, but can always be the case. So let me go into my TO. Let me go into my speed axis here. Let me go into my commissioning, and I should hopefully be able to start this now. If not, then this is going to break everything, and it's pretty bad because I can't continue from this point. Activate? Yes. This tells my PLC I will be the master of this controls. And now the enable. I could enable. Okay. I don't know why. I had to restart. Could be. Yeah, never freak out. Of course, in industry, you're always under time pressure, but try not to freak out. So this is okay. And now I want to go back to my trace as well. Now, the problem is if I open the trace, this might press emergency stop if I'm not fast enough. Whew. Ah, it did. Master control is returned due to violation of monitoring time. Right? Once we close this window here, right, that tells the PLC, danger, the one that is having control over your drive system right now isn't there. Right? So that's why closing this window or having another tab over it is dangerous. Right? Now this works. I should have just had that as a parallel tab there anyway. And now, I don't know why everything is scaled funky now. Oh God, why is that? Why is that the case? Okay, almost there. Scaling group 1, scaling group 1. Yes, please go in the same scaling group. And this is monitoring. And now I can enable my axis here. And now I can control the motor, right? Motor on, motor off, drive on, drive off. Like this would be the speed, right? Huh? Oh yeah, that's my set point. That's my set point. The real velocity right now is following 100% because the acceleration is extremely fast. No. That doesn't matter. It's okay. But we have a lot of parameters that we can use to change the machine's behavior here. Let's actually slow down the acceleration and deceleration a little bit. And that should now make it so that we can get a nice ramp, right? The red behavior is now what the motor will give us, right? Or what the conveyor will be. It will not just be on or off. We can, of course, control the acceleration and deceleration there. And if I have it very fast, it's just like a one-step thing. So we have those base parameters. Now, hidden in those base parameters are already hundreds of things from my perspective. This is magic, right? This is magic. Now, this stuff, the red lines, those would usually be like created inside of the drive itself. No. But we're taking this job right now. The PLC, the technology object, takes this job. Let me just see there. No, Emil, thank you for the hint with the TO version of 4.0. It should all work. I made it work just by turning it off and on. Yeah, there we go. Now there's more parameters. Let's have a more nice curve by also changing the jerk here. If you don't know what the jerk is, neither do I. Of course I do, but we will now have this much nicer curve behavior. This is what you want to have your motor be doing, right? And now we went from this on-off in your motor that we had, like the on-off. If I go to the base, back to the base parameters here, which was something like this, right? This is just on-off. Very bad. Oh, also this. On, off. The red thing, on, off, that's, imagine this is on your conveyor belt, something very sensitive is sitting on top of it, and now this is just on, this is bad. This is you in the car. Imagine if your car just has an on-off. This is how cars used to be, right? They had just on-off. Pretty bad. Right? Now we can change this, of course, to be much, much nicer. Much nicer behavior by just changing some parameters here. I'll change all of them to 5. That should be fine. Yeah. I know what yes, jerk is exactly the third derivative. I always say it way simpler actually. Right? Not as mathematical. Right? If I have an infinite jerk, or if the jerk is 0 as well, if I like deactivate the jerk, you see the acceleration. The acceleration here is just on or off. It's Boolean. The acceleration is directly, either you accelerate full or no acceleration. If you change the jerk a little bit, the acceleration itself, and that's the third derivative there, of course, the acceleration itself is going up and down. It's not instant, it's not binary anymore, which makes the thing much more complex. Right? Yeah, that's why I wanted to have the acceleration there. So it's the third derivative. In German, the jerk is the Ruck. Ruck is jerk, like in your car. If you just go full speed, all of a sudden you're pressed in the chair, and that's the jerk, right? That's the jerk. Like if you start too fast or too slow, that would be here your jerk, right? And if I set it to 0, I think 0 is fine as well, right? That will deactivate it. Yeah, that's pretty bad. That's not what we want. I mean, it is still okay because the acceleration deceleration is limited, but it is even making this much nicer. Now the thing is, right? The thing is, this of course takes place right now inside of the PLC. Usually this is already part of the drive, right? This calculation that we're doing, the red line there, is part of our drive train. Right? That is already in there, and we have already improved. Now the thing is, there is more to this, right? There is more to this. This is nice. This is already nice. This is pretty cool. But how do we actually get this to a motor? Now, what I could do, right? And now I will go back here, go offline, and I will close the speed axis control here for now. Right? What we do have is our speed axis here, right? This technology object. Very good question from Riff. Difficult there. What's the pros and cons when you control drive using Telegram and technology object? Let's get into the technology object. Very good question there, right? The technology object here itself has more configuration that we can do, right? Now this configuration will configure our technology object here. If I go in here, right, this is the last thing I want to talk about. We do have dynamic values, right? Which is not too important, but we have dynamic limits. What's the maximum speed of your controller? What's the maximum acceleration? Right? So how steep should those curves be that I just talked about? What should be the jerk? The smoothing time, right? Which I, for example, set to 5, which will make it so that the curve smooths out over 200 seconds. Doesn't matter, right? Doesn't matter, right? What's a ramp up, ramp down time? So going from 0 speed to maximum speed. What's like how fast will your analog output in this case, right? How fast will your motor accelerate, decelerate, right? huh, there's so many things going on. Right? And of course, we would now basically set all of this here, right? And one more thing that was in question early on, and this was, hey, what is off 1? What is off 2? What is off 3? Now we can also tell our PLC, right? We can tell our system in this case here, hey, what is your turning off behavior? And this basically 3 different things that we can do when we operate that like that we have control over right now. It's an off 1, an off 2, and an off 3. Right? Now those 3 are simply 3 different turning off behaviors. And I always mix them up, right? One of them is faster, right? One of them is with a curve, and one of them is a bit slower, right? Because we have 3 different applications. One of those is an emergency off, like where you need to stop as fast as possible. One of those is your standard off, right? The coast down is your standard, right? Where you want to ramp down slowly. Then you have your fast stop, your emergency thing, where you ramp down very fast. This could also sometimes be instantly. The problem with this is, of course, it is hard on your hardware. Imagine stopping a car or stopping a drive like instantly. You shouldn't always do that, right? And then you have a delay ramp, which just slows this down a little bit more in specific cases, right? So you do have different off behaviors for different cases. Yeah. And Jason is answering more questions there. Perfect. Hey, Logical Controls, you're so late today, sorry. And today I will try to just go for 40 more minutes. And there's so much more that we could discuss here. But that stuff you can already see Jason's jumping in there with the expert talk. Ah, there we go. Look at this. Off 1 is the standard. Sorry, yes, off 1 is the standard. Okay. Off 2 is the standard plus STO, whatever that is. I'm not, as I said, not an expert in this. And the fast stop here is emergency stop, or also if I do this, right now I have this on and I click enable, right? And this would be running now, and I switch the window, right, to anything else. Right? This also performs a fast stop. Safe talk off. Oh, nice. Safe talk. STO is safe talk off. That's such a great. Thank you. I've always been wondering. Safe talk off makes so much sense. Thank you very much. Yes. Now, all of this. The safe talk off means I always knew, of course, what it does. The safe talk off is basically saying, hey, just stop it right now. Stop it. Don't care about any safety there. Yeah. Oh, it just turns off the power there. Therefore, Jason. Okay, different. It just turns off the power, and it is like the motor is like slowly stopping. Then that makes sense. Fantastic. Now, all of those things, and this is my perspective. Now we're entering the area of drives perspective. That's why it's Jason having, and all of you experts in the drive section. That's perfect. Having you here. Now, my perspective on all of this is, I would just program this and give, and this is now where we enter those extended parameters. This is for me actually not too important. Right? It is kind of, but not too important. Now, what's important for me, of course, is how do I get this to my drive? Right? How do I get this to my drive? Because right now I do have my PLC, and of course, I do have my motor, which is connected to the conveyor belt, and in between we have the drive. Does not have to be a Siemens drive. And let me answer this question there, Pruna. If your motor has a brake, is STO applied to brake also? As far as I understand it, no. It's just austrudeln. In German, the word is austrudeln. I just know that, sorry, I'm German, I know the German stuff. Austrudeln would mean, like, it's just like slowly. Just, you don't accelerate, you don't decelerate. Just austrudeln. So, right now, right, how do we want to communicate through the drive? And there's basically 2 different things that we could do. An analog drive control, right? This is what you will see in very basic applications. Your PLC has an analog output module, and this analog output module communicates to the drive, right? With like with analog output and also with digital IOs. Right? Now, the second thing that you would usually have is a Profi drive exchange. Right? A Profi drive exchange works on a level where we talk about telegrams, which I will get into in a second here. I do not have a drive, though, in my project, so I don't have a telegram. Right? And there we go. I don't have a telegram. I don't have a drive. Right? Jason explains perfectly like the stuff there. I don't know what those parameters are. I just control them in my with my PLC program. Coast stop. See, I learned things. Austrudeln. So, what we can configure though is we can configure a so-called telegram for us. Now, a telegram will generate a lot of inputs and outputs that we control that we want to control. It's like digital inputs, digital outputs, analog inputs, analog outputs. There is a lot in those. And if I go to my device configuration here, which I can't because I don't have a drive, I want to say, how could I? Right? I will have to configure this drive telegram inside the drive. And you see there's different ones. Most of those are not Siemens specific. Some of them are. For now, I will let this to no telegram because I don't have a drive. Let's add a drive, though, to our project. Very quick, right? Very, very quick. As I said, I don't want to, like half an hour. I don't want to go over time. I'm not an expert in this. You see in the chat, way more expertise than I have right now. Now, what we can do, though, in our project is I can add a new device. And this is not part of the base package of TIA Portal, right? Now we can add drives, or other way around. If I leave this here to standard telegram, for example, right, I just have to set like my PLC is now going to shoot this into the network. Right? It's going to search for the drive. We have to still configure the drive it communicates to, but it doesn't have to be any like Siemens thing or so. So what I want though is to have this drive also in my TIA project right now. So I am using currently a software that is called Cinemix Start Drive, which is a plugin into TIA Portal. It's free. It comes with the TIA Portal license. You just have to download and install it additionally. So far, everything would be possible without. Now I am using the Start Drive, which is, if you Google it, Start Drive download or something. Start drive download, you will directly get to the download prompt within Siemens there. Right? And it would be this one there. You just download it, you install it, and you've got this now in TIA, which will allow you to implement drives. And very quick. And Jason there says, anything below Telegram 100 is standard telegrams, and everything above is Siemens specific. In this case, right? Start Drive is free, but DCC is not. I don't make the rules. Yeah. So let's see. Now, I have installed Start Drive though, so I will add a new device, I will add a new drive, and I will add a G120, for example, G120C or G120, I don't know. Always mix those up. I will just add a G. I haven't tested this. Doesn't matter. I will add a G120, this one. Doesn't matter actually right now. It doesn't matter too much right now. Let's see. How this can be controlled with CAN bus. Let me actually add this because I'm more familiar with this. Right now, this drive here, we will. You see, there's different sizes, different categories. I will just take like this one. I don't have hardware anyway that I can really show, but I will add the hardware here to my project. And I will get to one or two more smaller topics there. The Start Drive program should always work, yes. Now this device here, right? This is our control unit for the drive, right? Those things usually have three different parts, which is your control unit. So it has an intelligence in itself, right? So it can work in itself. we are now giving it the curve from the PLC, and the speed set point, everything is calculated from the PLC. But theoretically, this thing can work on itself. It's its own like smart little controller thingy, right? And you see it is Synamics, which is not. It's not my automation department. My automation department is Semantic, and not Synamics. Right? Siemens Dynamics. This is not my department there. Right? Now, what I still need to do is I need to tell this how big is the motor that you have there. Right? What is your so-called... Huh? Oh, this is already in there? Fascinating. Okay, no, this Leistungsteil, the power unit is already in there. Fascinating, that's what I chose there, I just realized. Huh, interesting. Yeah. Nevertheless, this is my drive now, right? This is connected to the motor. This is driving the thing. This is there. Now, what we need to set up, though, is the communication between this and our controller. So the nice curve that we just saw a minute ago, how does it get to the controller? With many different, and now this is where things get, hopefully I can set this up, probably, 1 second. Now they will need to communicate, so the drive itself is supposed to be coordinated with the PLC, so I'm going to assign it here to the PLC. Right. Now the drive is assigned to the PLC, and in the communication here, right, I have to tell the drive right now what is your telegram that we want to use, right? And I will now choose, and I'm on a drive right now, right? This is a drive, this is like the parameter, like the communication parameter there of the drive. Telegram configuration, the drive here wants to send data to the PLC using the standard Telegram 1. And there we see what Jason just said, like the Telegram 1 and 20, those are standard telegrams, and they're Siemens specific ones. We can also create our own one, but let's stay simple with standard Telegram 1. Inside of standard Telegram 1, we will find 2 words of, how's it called, PCD? Like 2 control words and 2, so 2 input words and 2 output words as well. So there will be a hole. Those drive names, I'm not even sorry for that. The regular G120 has SU. Okay. Thank you very much. I mean, it doesn't matter for what I'm explaining now, but thank you. That clears things up for me. So basically what this thing is now, right, is it has 2 words of inputs to my PLC, and it also has 2 words of outputs from my PLC, right? So I can use those 2 words, output 256 and also inputs 256, I can use in my PLC program, right? Hey, Tunnel. Good evening. Right? So what I could theoretically do now is inside of my PLC, I can go into my PLC tags, right? And I will just, split my window here for a second. And, what is this? Oh, that's the drive. Yeah. And I could add a new table. I would call this drive com or something. And inside of the drive com, I could set up a couple of variables, right, that I would just take from here, from my Telegram. And yeah, my window, my screen size is what it is. And now I could just set those up, right? Input 256. All right, 256, which is IW 256, sorry, is a word, right? This is my, I don't know how it is called right now. Wait, there is a word for it. Standard Telegram, the PCD. And Jason definitely knows what PCD is. In German, it is Zustandswort. And I don't know what it is in English. Right? Probably something, yes. I will just call it PCD. Right? The same I would have for the output here, which is then my control word. That also has a name. Now, all of this is irrelevant, right? But this is for me right now. This is also PCD1. Okay. I don't know how those are called. But this is my control. This is my status word. Now those two, they do give me I do evaluate the status. I put it in there before you said so. Zustandswort. I just know German words, but thank you very much. Yes. So those would be coming from the controller or to the controller. This is inside of our communication. Now, what we also have in there in the standard, like in the second word, right? The second word of this would be the which is then input word 258. Whoops. Right, is our speed, right? The speed feedback, and then we have also output word 258, which is our speed set point. Right? So we have all of those speed feedback. Current, speed current. Right? So we have those and we can use them inside of our PLC program as standard inputs, as standard outputs. I can now create this and use this in my PLC. Now, to be even more precise, right now inside of the drive, this status word and the control word and the speed set point and so on, they do exist as variables, and I do hope I can go into the parameterization. Right? And we have the parameter view here. The functional view, I always mix this up. Yeah. Just 1 second, I need to search for the right place. Inputs and outputs, probably this. Yeah, you see this, right? This is what the drive is going to get from us. It has those digital inputs, it has the outputs, and we can control those. Wait, no, those are not the right ones. Those are the physical ones. Where are the... Can't I get it from here? But you see there's... basically, in the end, what I want to get at, and I don't know where the... Do I have to monitor for this? It might be. Now, in there, right? You see we have many parameters that we want to control and can't control. Right? In communication. There. Ah, thank you very much. Yes, that's what I was searching for. Probably. Yeah, you see we have many things here that we can turn on and off. Right? Many parameters that we have, like the telegram here, and down here is probably the what's within the standard telegram. And you see there is quite a bit of stuff in there. And for me right now, right, if I click on this, you will see we do have a parameter for all of those things. Right, let's see. This is not what I want. The receive direction is what I want. Now, all of this is not irrelevant, but it is, like, from the PLC's perspective, those are now the outputs that I can use. I do have a PLC output. If I turn on the bit number 0 in this byte in this word that we had, right, I can turn on and off the drive here. Right? If I have this output, and we talked about this a little bit, it's the off to, the coast down. That Jason explained earlier on, right? Then we also have the bit number 2. If we turn this on, it's literally like a bit that we turn on inside the PLC program right now, right? That would lead to a quick stop, and so on. We do have many different outputs that we can use, and we also receive from the drive. This is now PLC program perspective again, right? Inside my PLC program, I can also see I do have an input, a bit that tells me, oh, the drive is ready for switching on. Oh, the drive is ready. Another tag tells me, oh, the operation of the drive is enabled. Oh, there is a fault present, and so on. I can use all of those inside of my PLC program, right? As individual bits, as individual, or as a word in total, but we have access to those, right? And that's what you would literally do. Like, you would now, I could write a program that uses that just controls those ins and those outs as any program. Right? Yeah. Let's see. Now, why are there was the question, why are there other telegrams like the standard telegram here? The standard telegram 1 is a very basic telegram. Right? Now you have much more complex, like the standard telegram isn't anything special. It's 16 bits that you can turn on or off, and not even all of those are being used. Now for more complex applications, of course, you need more control points that you can control and more feedbacks. So the more complex your application, the more complex your telegram will be. Simple as that. Usually, you would take a standard telegram for a standard application, like the standard one. It's the most easy one. It's the most simple one. You can make your own custom one if you want to. We will not do that. But we could. We could. Yeah, and this is what I'm leading into. I don't want to advertise Jason now too much because still on my channel, right? But Jason has a lot of knowledge in that direction, which I saw. So you inspired me to talk about this topic. There we go. Now, back to my perspective, right? Imagine I am completely overwhelmed by all of this. Pardon my French, holy shit, what is all of this? Whoa. If I go into the parameter view here, what the this is not okay. This is, for me, from the perspective of a PLC person, of the TIA person right now. What is holy schnitzel? Yes. Tran, you're saying it right. What is all of this? This is, oh no. You're not trying to, no. It's okay. Like we're talking knowledge, Jason. Right? We're talking knowledge, and knowledge should be shared. So I'm very happy that you also share your knowledge. Right? That's my honest opinion. If not, then I wouldn't be saying things. Right? But you see, there's tons of things. Whoa. From me, as the perspective as a PLC programmer, right? Holy shit, this is not okay. Right? Those aren't even all of them, exactly. So for me, I know, Bruno, I know that I am aware that this is only standard stuff. Now, for me, from the perspective of the PLC, I couldn't care less about those. Right? I also, and here comes the twist, from the perspective of the PLC, screw this as well. Right? I don't care about this at all. I'm going to delete this. Right? What I care about is I do care about my program, and I care about what my program does in the PLC. So, and that's the last part that I will add now. We can't really test anything because there is no, I can't simulate the drive really that much. But what I will do, instead of all of those things that like controlling anything manually, all of those parameters, I don't know what any of this is. What I do know is that I want my system to do what we had earlier on, right? And I will jump back to this now. What I know, screw all of this. Now, I'm exaggerating, of course, but that is industry. It is complex. I am a PLC control person. So, of course, I want to concentrate on the PLC side of things. Jason can have your side of things, that which is this, right? Now, what I care about is basically only this, right? So I will go online here, download this, turn it on. Yes, I know. Turn this on, monitor this, put those again into the same group here. The only thing I really care about, right, is why is all of this too much? Is me doing this, what I'm doing right now. Right? This is what I want the program to do. The program should be able to take master control. The program should be able to turn on the axis. Oh, by the way, turning on and off this axis here changes like 6 or 7 of those bits that we saw. Right? There are many interlocks that have to be activated inside of the drive, like in our telegram, that have to be turned on in order for the drive to be active. I don't know how many that is, but there's like 5 or 6 different ones that have to be turned on or off specifically. And I don't know what those are. And I, as a PLC programmer, don't care, right? I don't care. The parameter list hunts you like a ghost. Oh no, for me as well. It's crazy, right? All I care about is turning it on and then this, right? I want to be able to go forward and I want to be able to stop this thing, right? To go to a specific speed set point, for example. Or I want to, if there is an error, I want to be able to confirm that error if there is one. I also want to be able to disable the whole thing here again. Want to enable it again. I want to be able to turn on jog or there's different modes, but I want to be able to do plenty of those things. I want to make a quick stop. I want to have a ramping down time. I want to be able to control the acceleration and deceleration here. I want to be able to. This is the only stuff that I, from the controller perspective, care about. which hopefully you can understand, right? So Jason, you can have your drive stuff. I will stay with my controller stuff, right? So it's like 5 bits, yeah. And then you have to, exactly, there's even a sequence, as Jason says. You have to turn on 5 bits, and then you have to have a rising edge on bit number 0. Do I care? So what we do is we take advantage of what we have. Like, basically, I want in my PLC, I want to have this panel integrated into my program as easy as possible. There's the question from Leon. Can I do that trace thing with command tables? Yes, of course. You can, the trace thing just monitors your data. It just gives you, instead of like a discrete time view, instead of like, this is just right now, it gives you that time. You can have that with any kind of PLC stuff, yes. I also love traces for showing things. Every time I use traces, so yes, of course I love them. Okay, now, how would I implement this? Like this table, right? This table here. I'm just going to make a screenshot. How do I implement this easily in my program? Right. Let's see. I do have this here, for example. Right. This part I will call the enable part. Right. Then I do have another part here. Let's say this. Right. Is the speed set point or so. I will call this the speed part. I do have down here the acknowledge part or the reset part. Acknowledge or reset part. This resets the drive, right? So that is what I want to. This is what I need. I don't need all of this complex stuff. Right? Right? Nice jumper. Thank you. Thank you. Right? Right? This is what I need. Now, I also don't care about the single bits. I just care about those areas. And therefore, and now I have 10 minutes left and I don't even need 10 minutes. Right? We do have our technologies here. Right? And there is a motion control technology and there are our motion controller blocks. Right? And it is now so simple. Right? I do have a motion controller power block. I just pop that into my program here. Right? I will give this a data block. Yeah, sure, it's a function block, right? This motion controller block now is supposed to, and now drag and drop, control speed axis. Right? And this MC power, this one here, is the same thing as the enable. So if this block sees a true at the enable, right, and I will give this a new variable, I will call this enable. This is a global memory, whatever, just global memory, right, there, can go there. Right? Now, if this is true, my controller, my drive will be turned on. Right? This whole stuff that we do up there. Right? We don't even need to care about the telegram. Right? This will now happen because we have configured the speed, the technology object here. Right? Now, if I want to reset all of the alarms and everything, make a guess. Oh, there is a reset function. Is it? Pop that in here, right? Say which axis, this axis. Oh, it has an execute and a restart. The execute, I will put the reset here, right? Now reset or acknowledge. Reset or acknowledge, doesn't matter. There we go. I will have this, define the tag, global variable here, sure, why not? There we go. Now, if I want to go, the next thing, right, the next area, the speed, I want to go to a certain velocity. Hey, look at this. Who would have guessed move velocity? Or is it move absolute? I always mix those up. 1 second. No, absolute is position control. Right. Right. So right now, move velocity. Which axis? This axis. When do you want to execute this? Well, when I press the run button or so. Right? When I have the run command, I will define this. Global memory again. If this turns on, axis is supposed to start. Now, with which velocity? This could be a variable. This could be a variable. This could be the velocity, acceleration, deceleration, jerk. All variables, right? All of those things that I have here, those are now my variables, my input variables to this block. Now all that I have, and also the direction, right, forward, reverse, is also an input. That's it. I literally just have those PLC variables now that control the whole thing. That's literally it. I also have a stop, right? The stop will make it so that it goes to 0. Yes, Jason has the jog, and there's more, right? The move jog is basically what I have been doing because the thing was only active as long as I pressed it, right? If I released it, it went back to 0. That's the jog. I now have the move velocity, which will stay at that velocity. So now if I download my program, now Ignatius says if you don't tune the driver and so on, of course those won't help, right? This is the base level, not going into drives too much, right? Logic Controls asks, no, this technology objects, they are also available for the 1200s, yeah. Pretty cool stuff, actually. Very powerful, but pretty cool stuff. So now if I go back into my, where do I have? I will now, and this is, I haven't tested this. But I will have my variables now go in here, and maybe I can really control the drive. I haven't tested this, so if it doesn't work, please don't blame me. I did not mean to. Or maybe, let's have one more. One more variable. I still have 8 minutes, come on. The variable velocity. At this velocity, global memory, wherever that goes, I don't care about it. And this also goes into my watch table. Yes. Velocity I can spell. Velocity. So this velocity, I want to give a value, for example, 100, it doesn't matter. There we go. Right. Now if I download my program, we can control this drive. Theoretically, I can really not guarantee that it works right now because I haven't tested this part. Maybe it does. It should actually. Right. We should now be able to control our PLC, our drive. And this now has to do, right? This will control the telegram, it will give the drive the command, and so on. Like all is in there. This is not, this is kind of pointer, yes. Don't look at that too much. Stop it. Don't care about memories, but yeah. There we go. And now theoretically, if I turn those things on or off, right, I should be able, right, to run this thing, which I'm not, as I said, it might be that I'm missing something. Wait, no, this is not correct. Modify. Huh? Why is it not doing the thing? Modify it. Something is missing. But that is now how we would control the drive. Let me just see what's missing. Why isn't it doing its thing? There might be an error or so. As I said, I haven't tested this part. Let's see. This axis should be enabled. It should be in some mode. It's busy right now. Status is true, which is okay. The axis... Maybe I still have to reset the whole thing once, which I think I do. So let me reset the whole thing once. Yoink. And now, let me see. Modify to 0, modify to 1. Yeah, there we go. Right. I had to reset this once. There we go. And because I have the speed, right? Because I have this one, I have used the move velocity one, right? Even if I turn off the run button, the PLC will stay at that velocity. Now if I go back to my watch table here, if I want to change the velocity, for example, I can now do that here in my program. But what I have to do still is I have to click the run button, of course. Oh, I have to also... Sorry. I did not change the thing. Now I have to, of course, hit. And it will go to 50 with all of the parameters that we had. Very, very, very cool stuff. Right. Now, of course, the perspective... This is the PLC perspective now. Right. I have to react to your reaction there. Wait, did you make another one? I didn't see another one. Sorry. Yes, with the motion control jog, you can change without the positive edge. So if I just want to be able to do what I did before, I will not use the move velocity block here, right? Which this will now be renamed into move velocity. Right. If I want to be able to just do the jog, I want to add the move jog into my program here. Right. Which axis, because you could have multiple, of course, connected here, move there, this should be my velocity. And I can have move jog forward, jog backwards, right? I will call this forward and backward. Would you really call it backward? I would have called it reverse, but that's just naming. Forward, reverse, and you see I will just create variables all over the place. Of course, we could now also control the jerk and acceleration, deceleration, right? Those are just variables now that we could have on an HMI or wherever. Right? Sure, no problem. It would be very, very fast, very quick, very easy. Now I want to have those, of course, in my, 1 second, in my watch table. Those are new, right? Forward, reward. There we go. Quickly download the program, and now we can also, because Jason mentioned it now a couple of times, we can also use the move jog, which will allow us to give those parameters to the drive. Yes. Right. Using the watch table now. And now we could move velocity. I will turn off. This thing will stay at the velocity because move velocity is, if we turn it on, then it will stay there. That is different to the jog here, which is then forward and reverse, or forward and backward. So if I have the backward, you will see it goes through the 0 point. All the calculation of how this S-curve works is inside the controller. I don't care about it. Right? And if I want to go back forward, right, I'll just hit the true button there. Fantastic stuff. Stream together with Jason would be awesome. Maybe at some point. Yeah, there we go. Right. Funny stuff. Oh, one thing that I want to add. Ooh. Just so we can see things going on. Right. Because I will be now phasing out the stream, actually. I want to add one thing to our hardware here. Enable the use of the clock memory byte. Now this will go to byte number 50 or whatever. And I do have now clock frequencies here. And I want to put those clock frequencies to my block here so that we can actually see like the curve going. So let's see. The jog forward should be, and I will now put this on not forward, but clock maybe 1 hertz in combination with clock 2 hertz. Now this will look stupid, but that's fine. This is going to be fun. Because I want to see this moving. If I'm phasing out the stream, right, we want to see things move. Now this is okay. The trace has gone offline. In a second, I will be back with chat. Sorry there for a second. Now this is all downloading this and monitoring it. There it is. I do not like that I have to every time click on the scaling group again. This is kind of annoying, I gotta say. But it's okay. Now in the watch table, I can do that stuff. Huh? Did I not? Did I not download the hardware? Thought I did. I did not download the hardware apparently. And now if I go online. No, I didn't. I remember I did not. Wait, I did. Hey, it's not enabled anymore. Why is it not enabled? True. Reset knowledge. True. And false. Move velocity. And velocity, of course, is wrong as well. There we go. And now we will have kind of a fancy behavior. Hey, look at this. We actually have oscillations. Yeah. But we do have this nice motor behavior now, which is much nicer than what we had beforehand. Pretty dope. Pretty dope stuff. Now, all of this, of course, controllers, especially drives, are much more complex, right? Much, much more complex. But yeah. Let's see. But does TI Portal do camming and gearing with virtual axes? Yes, it does, but not in this sense, right? There's more. There's many more things right now. Right? This is just the intro here to the technology object and to like how to connect the drive. All of this can be done many different ways, but that is one way that we can go in there. There's way more to it. Way more to it. Let's see. Subscribe to Jason. Perfect. Subscribe to me as well. Get my Udemy training while you're on it. Time for off 3. I will not. I mean, I can turn on and off the off parameters now. For example, I can now. No, I can't control this anymore. Shit. Now I will not make. Sorry for me cursing. Why did I curse all of a sudden? This is forward as well. So if forward is on, it's going to do that fancy stuff. Forward is off though. Yeah, now we can control this thing so nicely. This is fun. Let's see. Should join the Discord channel. I am so lazy. I do the TI Tuesdays and I try to get in on stuff. I do have my own Discord, which I barely use at all. Yeah. So Jason says, if we use the MC power function with the correct parameters, it will drop the off 3. Of course, there's so many more things, and that's what's interesting about this. But my perspective from the controller, right now, this is how I can run the drive now. This is how I can connect things to the drive. This is actually quite easy. You see this? There are different stop modes. You're correct. Not going in details with this now, right? I don't want to go too long as I usually do, but I think all of this topic is quite interesting. For me, it is. Like, this is cool stuff. And now let me turn on the forward again. Yep. And it's going to be... This is me driving a car, by the way. The set point is 40. Right? And I'm like, I'm going fast, going slow, going slow. Yeah. The help function is really good for those MC for the technology functions, right? The help function is really good. And there's way more that we could do right now. As I said, like, yeah. In applications where precision is required, of course, this. So Arteco asks, what's with applications where precision is not required? Oh, not required. Um, there are many different setups, right, that we could have, right? If I, for example, go into my into the drive that we have set up, actually, what I'm doing here, this will not right now control the drive as I have set it up. Right? Because right now the drive, if I go into its commissioning of the drive itself, the drive currently, right, depends on your setup. There's many different ones. Currently, the standard setup for the drive is that the ramp function is generated in the drive itself. What we have now, what we would like to use now, is that the ramp function is generated by the PLC. A very normal setup is though that it is in the drive. Right? It is just one of those examples where the PLC nowadays is taking the job away from other technical components. Right? So that's what we would have in this case. This is there in the 1200 series, yes. Yeah. But as I said, this whole topic is of course complex. We we have an in view of like an hour now, so this is fun. Like this is great stuff, and there's, as I said, way more parameters that we can do. I'm not an expert in drives, so I click on cancel. I will say no. I will not touch those like thousands of parameters. Those are crazy magic to me. Like this stuff. I would probably still understand most of it, but not all of it. I'm not an expert in this. Perfect. This is fun, right? This is cool stuff. This is like drives. This is an intro to drives. This is how deep I, as a PLC programmer, this is how deep I go into drives, pretty much. Right? I don't really need to go deeper. That is where the interface is, right? This was my interface here. I have now set up my user program with the technology objects. I have set up the technology objects with some parameters. Some other person usually would be responsible for the drive and motor side, which is so much complexity in there. And to be frank, not my personal expertise. And it's fine. I understand parts of it, but you will also not be an expert in everything, most likely, right? So PLC part, that would be me. That is on me, right? I will take over this part, and then we have Jason there on the other side, and many more, right? You've been doing a lot of discussions there. That's great, right? But that other part, sorry, I messed up your name there, but still, that is on the drives engineer side. What does simulation do? I have not really worked with this active simulation thing. Activate simulation, but I can go over this, virtual axes in simulation. I can open the TIA help viewer, and I could read, of course, into this. You can use these functions with analog controls. I could just set the drive exchange here. Oh, right. I said we had the data exchange with Telegram, right? We could also have the data the exchange here with an analog, right? And now we would just have an analog card connected to the motor. Exactly what Jason says, but I was kind of faster. But yeah. There we go. And then the axis in simulation motion control offers the option to move real axis in simulation speed positioning, synchronous axis. Oh, it is if you have a real axis and you want to go with simulation speed as well. Okay, yeah, makes sense. Let's see. Okay, so that was my part on drives now, right? I'm not an expert. That's the main outcome that we take from this. I'm not a drives expert, and that's fine. I'm not ashamed of it. Just a bit. Good. I will now make my face bigger to phase out for the day because my girlfriend also just got home. So I want to spend some time with her as well. I'm not going to go too long today. Yes. Technology objects work with TM cards. Yeah, there we go. Let's see. It would be nice if I can call the controls guy when I have a problem. there is always jokes going on, right? Like depending on the perspective. like you always blame the next level, right? Then you have the electrical guy will be blamed, the programmer will be blamed, the drives guy will be blamed, the operator will be blamed, the physicist that came up with the physics behind all of this will be blamed. There's this whole chain there, right? The technology module is for high-speed counters, for example. There's different technology modules, but high-speed counters, yeah, depending on. But usually, like if you have high-speed stuff, you will need a TM. You blame the flux, for example, which would kind of go into the physicist level, I would say. uh, and also, hi Isaac, but I'm slowly phasing out here. I would say thank you very much for joining. This is fun. This was a fun one. I am, as I said, not the drives expert, but that was definitely something that I had here on my list, which isn't 100% covered now, but I will still put an X there because I was like, yeah, what can I put, like which things, what can I talk about there? Just a bit. And it also was continued with our technology objects, right? Cool stuff. Yeah. It might also be like mechanical programming, right? Awesome stream. Thank you, Delian. Yeah, and thanks Jason as well, of course. Like answering all of those questions in the chat there. You are way more confident in the whole topic than me, which of course, and that's fine. This is the only way it works. Like working together. Yeah, perfect. Good. Then I would say we all deserve to take some rest, not depending on the time wherever you are. But for me, it's now 8 p.m. a little bit after 8 p.m. So I will now phase out, have a quiet evening here, sit on the couch a little bit. Will I talk about? So if you have questions now, put them now in the chat because as I'm phasing out, I will still try to answer them. Will I talk about IO Link? I have it on my list. So I will try to get into as many things as I can, right? You see, every week we are adding more topics than we're subtracting from the list, but still trying to get through as much as I can. Yeah, perfect. So before we add anything more on the list, thank you all for joining. So I will hide the list from you now. Thank you all for joining. I will click on the save button. I will put this block that we did. You don't wait. I will at some point publish this, but still right now I will, of course, whatever we did now, I am going to add a folder here. I will call this folder drives. Plus the date. What's today? 25/12/02. And I will put the PLC in there, and we do have this stored now. So our TIA Tuesday library is growing. At some point, I'm going to publish it. Right? Alrighty. I would say I'll see you next Tuesday. For those that haven't, get my Udemy meeting. I need to advertise. I don't need to, right? Why would I? No, have a great evening. Have a great week. Thank you so much for joining. Right? Especially Jason, right? Helping a lot there in the chat. And everyone else that participated, especially in the chat. Thank you so much. Right? I'm enjoying this. This is great. This is a lot of fun for me as well. So maybe today I can find the correct button. Have a great week, everyone. I'll see you latest next Tuesday. Bye-bye.